Yesterday we started talking about what ratios were and how to write a ratio. Today we're going to be exploring what equivalent ratios are. So, as you can see on the board, you have 3 examples of equivalent ratios. You have 3 pies. All of them are half, but they're just split into different parts, but they all have the same ratio. Same with 3/4. If you were to multiply your numerator times 4, you would get 12, and the denominator times 4, you get 16. A fraction is also a ratio. Okay? And over here you can see that 2 to 6 is the same as 1 to 3. Alright, a website sells song downloads for $2 each and movie downloads for $5 each. So we already know what our ratio is going to be. 2 to 5. That's our original ratio. Your friends buy the same number of movies as songs. If he spends $20 on movies, how much does he spend on songs? Okay, so originally we know that each movie is $5 and each song is $2. If he spends $20 on movies, you've got to figure out how many movies that would be in order to figure out how much he spent on songs. Well, 5 times 4 is 20, so he must have bought 4 movies. Okay? And whenever you multiply one part of the ratio by, you have to multiply times the other. 2 times 4. Alright, this is one way to do it. Another way you can do this is by creating a multiplication table. You can multiply the numbers on the side of the numbers above. So 1 would be 1. 1 times 2 would be 2. 1 times 33, 4, and 5. You're going to do the same thing with numbers going down. 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4, and 5. And you're going to keep doing this over and over again. Now you're going to do 2. 2 times 2. Oh, whoops. I don't know why it does that. 2 times 2 would be 4. And you're going to keep on going down the ratio table. Sorry, I just erased it all. So as you fill it out, that'll kind of help you create what we're about to do. We have our essential question. I want you to copy into your notebook. Can you use one ratio to write another? And why might you want to do this? Okay, pause the video so you can copy it down and push play when you're ready. Okay, so copy this into your notebook. I gave you guys a ratio table to work with, but if you want to recreate one, you can. I can just copy one that was given to you. You need to know what an equivalent ratio is. An equivalent ratio are ratios that express the same relationship. You can find equivalent ratios in multiplication table. So say you had a ratio that was 10 to 15. You can use rows and columns in multiplication table to find equivalent ratios. The term of the ratio, 10 to 15, are in the 5's column in the multiplication table. Okay, copy this down. When you finish, push play. Alright, so as you can see, 10 to 15 is right here. That means all numbers that are in the same column are included in similar ratios. So 10 to 15 is the same as saying 2/3. Another equivalent ratio to 10 to 15 is 4/6, 6/9, and 8/12. Those are all lesser terms. They're all equivalent ratios, but they're just smaller. Okay? You don't have to use the table, guys, when you're solving this. I'm just showing you a way to figure out ratios. There are also some greater terms. So again, these are the same as 2/3 or 10/15. They're just with bigger numbers or smaller pieces. Okay? Alright, and then they can do multiples. This is what Miss Kennedy likes to do. I know that 10/15 10/15 can be reduced to 2/3 by division, and 2/3 can be increased to 10/15 by multiplication. It'll still be the same ratio, just with different numbers. Just like, let's say you had a candy bar, and your candy bar was broken up into thirds. If you were to eat 2/3 of the candy bar, it doesn't matter how many pieces was in those 2/3. It could have been like a bunch of pieces in there. You still ate 2/3 of the candy bar. Even though the candy bar might have had 15 parts of it, if you'd eaten this much, you'd eaten about 2/3 of it. Okay? That's sort of how this is going to work. Let's keep going. Alright, we're going to use the multiplication table to find the ratio that is equivalent to 12 to 16. So what you are going to do is you're going to find your 12 and your 16. Alright, so 12, as you can see, is right here. And your 16 is right next door. You could do it this way, or this way. The thing about finding ratios on this chart is your numbers can be vertical to each other or horizontal to each other, but they cannot be diagonal. So you can't just circle this 12 down here. These are a ratio. It would have to be here. It could be down this way somewhere, but they have to be on the same line here or the same way this way. Okay? So 12 to 16. They are on the same line as 3 to 4. Okay? You can do it this way, or you can prove it mathematically. 12 to 16 can be reduced. And they can be reduced by 4. 12 will turn into 3, which you have here, and your 16 will turn into 4. Sorry, my computer keeps glitching, and so I keep trying things over. Okay, that lets you know that the 3 and 4 column are in the right spot. Alright, let's move on. Will you erase, please? Eraser? Thanks. Use the multiplication table to find the ratio that is equivalent to 24 to 28. Find one ratio with lower terms and one ratio with greater terms. So the first thing to do is find 24 and 28. Okay? Since 24 and 28 are side by side, you're going to be going up and down in those columns. Okay? Your goal is to find a lower ratio and a greater ratio. Okay? 18 and 21 is an equivalent ratio. They don't have that one listed in our options. So let's keep going. 12 and 14. That's the lower ratio. They have it on C. What about 3 to 35? Yep. So the correct answer for this situation would be C. Alright, let's keep going. Completely equivalent ratios. So, here, if you're not sure how to do this, you can fill this in, because 5 times 3 is 15, 5 times 4 would be 20, and then 5 times 6, 30, 35. You can do it this way, or you can do the fill in the blank way. So you need to locate 21 to 24 on your chart. Well, 8 times 3 is 24. So something else times 3 is going to be 21. And that would be 7. Okay? So that means that you're going to be working in the 7/8 column. So let's say you're going to 49. You've got to figure out what the 8th column is. Well, 7 times 7 is 49. So you got to figure out what 8 times 7 is. to find the missing value? Well, we know that 8 times 7 is 56. So your missing value here is 56. Okay? Let's do this. Let's keep going. So we have 15 to 21. We knew that 21 was right here. All right? So we have 15 and 21 together. That means you're going to be working in column 5 and column 7. Alright? You need to move your circles until you figure out where the 49 is. So, it's going to be in the 7th column. 7 times 7 is 49. So you got to figure out what 5 times 7 is. 5 times 7 is 35. Whoops. Go back. Alright? Let's do it one more time. Do this one along with me, please. You have 25 to 35. Okay? Well, as you can see, 25 and 35 are going to be in the 5 column and the 7 column again. You need to go until you find 15. So 15 is located in the 5 and 3 column. So you're going to pull your other circle so that way it's even with this one. 7 times 3 will give you your missing value. Well, 7 times 3 is 21. Okay? Let's start doing a visual of how this works. You can also use multiplication in your head if you're really good at multiplication tables. Ooh, I just want this to erase. Alright, complete the equivalent ratios. Blank to 28 is equal to 18 to 36. Well, you don't have 36 listed, but on your 9s column, you know that 9 times 4 is 36. So you know your values are here. So now you got to move your circle up so you get to 28. That means your 18 circle is going to go here, because they have to be side by side. 7 times 2 is 14. Whoops. Circle that just braces. Alright. We have one more thing we're going to do before we finish up. So solve this problem in your notebook. I want you to, I'll show you the book. In one class, 3 out of every 8 students have braces. So stop there. Think about it. What is your initial ratio going to be before you move on? 3 out of every 8 students have braces. Well, that's written as 3 to 8. Okay? Now I'll keep going. If there are 32 students in the class, how many of the students have braces? So let's think about it. 3 out of every 8 students have braces. We've got to figure out 8 times what will give you 32, because that is of the reduced value. Well, 8 times 4 is 32. So now you got to figure out what your other number is for the ratio. Well, we'll just do 3 times 4, because whatever you do to one side, you have to do the other. 3 times 4 will give you 12. That means 12 of 32 students have braces. Okay? And write that one. Alright, in this lesson we learned about equivalent ratios. Can you use one ratio to write another? Why might you want to do this? Alright, think about this, guys, and then when you think you got it, you can go ahead and get started on your digits.